Welcome to Episode 3 of Foundations of General Emergence Mechanics. We will be discussing the Z_2 chiral bias and why the potential tilts. So far, we've explored the symmetric Z_3 potential, which has three equivalent minima, as shown in the graph. Today, we ask what happens when a directional preference is introduced. Recall the Z_3 potential formula, Vz_3 of theta, which is perfectly symmetric and yields three equivalent minima with no preferred direction yet. We introduce the bias potential, V bias of theta, which represents the first directional asymmetry. It introduces a preferred direction and tilts the baseline structure without replacing it. The bias term can also be written as a single cosine function. This form shows a clearer geometry, indicating the preferred direction at 60 degrees or pi over 3 radians. The square root of 3 factor is geometric, coming from directional projection at 60 degrees. Here, we see the relationship between cosine 60 and sine 60 degrees. When the bias enters, the landscape changes from 3 equivalent wells to a tilted potential. This introduces a directional preference, as seen in the right graph. The bias has now entered, but the coherent stiffness has not yet been added. The final corrected minimum is still to be determined. To summarize, Z_3 gave the baseline, Z_2 introduced directional asymmetry, the square root of 3 factor comes from geometry, and the potential now tilts. A question to consider: if the symmetric potential already has 3 minima, does the chiral bias add a new minimum or a preference among existing possibilities? Join us in Episode 4, where we will discuss coherent stiffness, the missing dynamical correction to complete our model.